This is Milani, Chapter 13, Section 3, Problem number 2. In this problem, again, is going to be almost like a review from 13.1, 13.2, and 13.3. And I'm going to show you the shortcut how to work in this problem. But the first thing you do, you always find the domain. In this problem, I do not have any restriction. Domain is from minus infinitive to positive infinitive. In order to find a critical point, concave up, concave down, we need to find the first derivative from this. The first derivative from this is going to be 6x exponent to minus 8x. At the same time, I'm going to find the second derivative, which from here, the second derivative is going to be 12x minus 8. Now, in order for us to find a critical point, we will use the first derivative. I indicated here CP as a critical point. You are going to use your first derivative. You set it equals 0 to solve for x. In this problem, the first thing you do, you factor the GCF. Number-wise is 2, letter-wise is x. That means 2x is the GCF. When I factor the 2x from 6x exponent to 3x is left. When I factor the 2x from minus 8x, minus 4 is left. Now, each individual, we are going to set it equal 0, solve for x. 2x is equal 0. Divide both sides by 2, which from here, x is equal 0. From here, move the minus 4 to the other side, and then divide both sides by 3. Which is going to be 4 over 3, or we can indicate it as a 1.33. That means I have two critical numbers here, but we need a critical point. I need a y value. For any y value, you always go to the original problem. It means you find f of a 0. Go to the original problem, replace all your x's by 0. My y is going to be 2. Then I have one more critical number. Replace the x in your original problem with the 1.33, and then replace the x by the 1.33, and that is going to be your answer. Then critical point, in this one I indicated number, but is actually critical point. I have two of them. X is 0, my y is 2. X is 1.33, my y is going to be minus 0.37. Again, I have two critical number. Then, draw the line. Label your critical point. X is 0. My y is 2, plot the point above your line. X is 1.33, my y is negative, plot the point below. Now, to find the relative max, the relative min, the way we learn from 13.1, 13.2. First, we have to find the increasing, decreasing, by using the testing point on the first derivative, and then after finding increasing, decreasing, you are going to be able to find the relative max, relative min. But now I'm going to show you the shortcut. Just please pay attention to this part. It is easy if you pay attention. On the shortcut, you will go to the second derivative. That means you will use your second derivative and you plug the x coordinate of your critical point. That means you are going to find f time of a 4 over 3, or you can just say 1.33. That's the reason I put an opposite number here to let you guys know it doesn't matter. The main things I'm concerned, if my answer is going to be negative or positive. Right here, if I multiply the 12 by 1.33, your number definitely is larger than minus 8. Then it's going to be 8. Now, if my answer is going to be positive 1 or positive zillion, it doesn't matter. That means my answer is the positive number. If the answer is the positive, it means in this area, my graph is upward. If it is upward, look at this point. This is my vertex, which is relative mean. That means when the x is 1.33, don't forget, that is not the y coordinate. This is just the testing number, which you do not look at it anymore. When the x is 1.33, don't forget, right here, this is my y value. Then this y value is going to be minus 0.33. That is going to be my relative mean. But I have one more critical number, which is 0. Then you are going to say f double prime of a 0. Then replace this x by 0. This one is becomes 0. I have a minus 8. Again, it doesn't matter, minus 1 or minus zillion. My answer is minus. If the answer is minus, that means my graph is downward. If the graph is this shape, this is the highest curve on your graph, my vertex, and that means is the highest. That means it's going to be relative max. X is 0, my y is 2. Now, we find the relative mean, relative max. We need to find the increasing, decreasing. But by looking at your graph, remember, relative max, it happened when your graph was increasing and then to decreasing. Relative mean, it happened when your graph is decreasing and then increasing. Then by looking at this graph, this is the part which my graph is going down. That means my decreasing is between 0 to 1.33. Now, increasing, this part is going up, this part is going up. But don't forget, this one is going to start from minus infinity to 0. And again, you have one more from here, which the x is 1.33 to positive infinity. Then that was the easiest way we can find increasing, decreasing, relative max, and relative mean. Now, we are trying to find a concave up. To find a concave up, we will use the second derivative. Set your second derivative bigger than 0, solve for x. Move the minus 8 to the other side, this becomes positive 8. Divide both sides by 12. Then reduce, which is x is going to be bigger than 0.66. But bigger. Bigger means right side. That means bigger. That means from 0.066 to positive infinity. That is my concave up. Then, in order for us to find the concave down, the second derivative, you set it less than 0. Solve for x. Move the minus 8 to the other side. You are trying to solve for x. Get rid of this 12. Divide both sides by 12. Then, again reduce. X is going to be less than 0.66. Then, on the left side, that means my concave down is going to be from minus infinity to 0.66. Now, we need to find the inflection point. To find the inflection point, first you have to pay attention to two things. The first thing is the domain, is all real numbers. The second thing, start or the end of your concavitives is carbon copy. That means that yes, I do have an inflection point. To find the IP inflection point, your second derivative, you said that equals 0, solve for x. Move the minus a to the other side and then divide both sides by 12, which is x is going to be equal 0.66. This is the x coordinate for inflection point. I need a y value. That means I have to find f of 0.66. Go to the original problem, replace this x by 0.66, and then plug it on the calculator, get the answer, which my answer is going to be 0.81. X is 0.66, my y is 0.81. That is going to be my IP, which means inflection point. Again, we find everything